Hello everyone. In this lecture, I shall discuss the Laplace transforms in a single shot. The objective of this single shot lecture is that to understand the Laplace transforms, the whole things at one time. But the thing is that this lecture will be helpful to the students only when they have a overall knowledge, they have a basic knowledge on the individual things. So for which you should go through the individual lectures on the topics where the detailed discussion has been made, many solved examples has been made. Actually, I am preparing this video on request of many of my students. So it will be helpful to you, but at the same time, for detailed study, you should learn the individual lectures what has been uploaded in this lecture series. So now coming to the Laplace transforms. So let me to recall you the Laplace transforms. I can say the existence condition here. You know the definition of the Laplace transform. L of ft is integral 0 to infinity e to the power minus st into ft dt. Right? T is time variable. It is positive and s is a parameter. It is greater than 0. To make this negative time sign to a sense, it is greater than 0. However, in broad sense, s may be a real or complex variable, but here we are discussing the real sense. So, when the function ft is piecewise continuous, mark the condition 1, piecewise continuous, and the second condition is exponentially bounded, mark this condition 2i, right? Exponentially bounded means ft mod is less than k to the power gamma t. If these two condition holds, then we can say the Laplace transform exists, right? And the Laplace transform exists means chances of convergency of this integral, as it is an infinite integral, the chances of convergence is there, and this integral, after you evaluate this integral, so in place of t we are substituting 0 and infinite, so this will be purely a function of s. This will be a function of s only. So therefore we can say Laplace transformation of ft is f of s, right? However, if we talk about the inverse Laplace transformation, we just reverse it out. We bring L to this side. What is your L inverse? Your L inverse of fs will be equal to f of t, right? So at this moment, we just remember inverse Laplace transforms as a reverse of the Laplace transforms. We have a direct formula for the Laplace transforms, but we don't have a direct formula like this. We may have, but currently we are not discussing that. I say that directly we may not have a formula at this right moment to get the inverse Laplace transforms. Now, as I said, this condition is sufficient condition only. I can say this is the existence condition of the Laplace transforms, right? This is the existence condition of Laplace transform. But this condition is only sufficient only. Okay, sufficient only. That means even if I and 2i holds, L of ft means even if I and 2i doesn't hold, right? Doesn't hold, but L of ft exists also, right? So that's why this condition is called sufficient condition only. Okay. Once I and 2i holds, this integral will converge and Laplace exist. Now there are certain cases this I and 2i doesn't hold, still the Laplace transform also exists. So this is the existence conditions. So without much delay on the vivid knowledge on this topic, let us recall all this formula and let us develop a problem solving approach simultaneously and adopt the various technique, and which technique is beneficial on instant problem solving we'll see now. So without much delay, let me to remind you the formula. If ft is 1, then Laplace transform is 1 by s. If it is t, it is 1 by s square. If it is t square, it is factorial 2 by s to the power 3. Likewise, if it is here t to the power n, then it is factorial n by s to the power n plus 1 when n positive, when n is a integer, positive integer either I say, and it is here gamma n plus 1 divided by s to the power n plus 1 for n is a real number. Okay. So now if it is e to the power at, it is 1 by s minus a, e to the power minus at, 1 by s plus a. Likewise, if I say what is a to the power t, a to the power t, it is 1 by s minus ln a. If I say sin omega t, it is omega by s square plus omega square. Cos omega t, it is s by s square plus omega square. If it is sin hyperbolic omega t, so this plus sign will minus here, omega by s square minus omega square. If it is cos hyperbolic omega t, then it will be s by s square minus omega square. So recalling the gamma function here, your gamma n plus 1 is n gamma n. Okay, and it is your factorial n when n is a positive integer. And here gamma of half is your root over of pi. Okay, so coming to, if I ask you what is Laplace transformation of t to the power half, it is gamma 3 by 2 by s to the power 3 by 2. You see this formula, so that will be gamma 3 by 2. Coming to this formula, it is half gamma half divided by s to the power 3 by 2. So this will be here half gamma half is root pi divided by s to the power 3 by 2. This is root over of pi divided by 2s to the power 3 by 2. Likewise, if I ask what is the Laplace transformation of t to the power minus half, okay, it is gamma minus half plus 1 by s to the power minus half plus 1. So this is equal to gamma of half divided by s to the power half. Gamma half is root over of pi and by s, so root over of pi by s. Okay. Now coming to one more formula, L of tft is equal to minus d by ds of fs. Based on this formula, we have certain important formulas to be remembered. If I ask you Laplace transformation of t sin omega t, then actually what we are doing, minus d by ds of this sin omega t will give you omega by s square plus omega square, and we need to differentiate it with a negative sign here. So this will be 2 omega s by s square plus omega square whole square. Okay, now on this basis, I just remind you all this formula. So Laplace transformation of t sin omega t, t sin omega t is 2 omega s by s square plus omega square whole square. Similarly, Laplace transformation of 2 cos omega t will be s square minus omega square by s square plus omega square whole square. Similarly, if I ask Laplace transformation of t sin hyperbolic omega t, then it will be just negative here. It is 2 omega s by s square minus omega square whole square. Similarly, if I ask Laplace transformation of t cos hyperbolic omega t, so here minus will be plus, plus will be minus. It is s square plus omega square by s square minus omega square whole square. Okay, so you should remember it as formulas so that the problem solving will be better. Now let me to recall you the convolution theorem. As you know, the product of the functions, okay, L of ft into gt, it cannot be L of ft into L of gt, L of gt. So to overcome this, we use the convolution. So what is ft convolution gt? The formula is integral 0 to t f of u into g of t minus u du. Okay, so now this product function can be overcome by this convolution theorem. So what is the convolution theorem? Now we have L inverse of fs into gs is ft convolution gt. Okay, ft convolution gt. Therefore I can say L of, if bringing L to this side, here ft convolution gt will be equal to L of ft into L of gt. Okay, L of gt. You see, so this is here fs into gs, right? So to deal with the product function, we have, this is the convolution theorem. Okay, but this direct product is not possible. Okay, direct this cannot be. So to overcome this, we have the convolution theorem. Recalling the properties, here f convolution g is g convolution f, f convolution g convolution h is f convolution g convolution h. This is your associative property, this is your commutative property, likewise. Okay, the details property you should see the individual lectures. Now my intention is to tell you here how this will help you. If I ask you what is sine omega t, convolution sine omega t, so then that will be integral 0 to t, first t is replaced by u, sine omega u, second t is replaced by t minus u into sine omega t minus u du. Okay, so to get apply a formula, we need 2 sine a sine b, and it is yet to balance it we need half, and we apply 2 sine a sine b and so on. If we simplify it, it will give me sine omega t minus omega t cos omega t divided by 2 omega. Okay, similarly, so to write all the formulas at a glance, sine omega t convolution sine omega t is sine omega t minus omega t cos omega t divided by 2 omega. Then cos omega t convolution cos omega t is sine omega t plus omega t cos omega t divided by 2 omega. Then sine cos sine omega t convolution cos omega t is here t sine omega t divided by 2. So let me to tell you how this formula will help you. Okay, if you are asked, suppose find L inverse of omega s square by, suppose I say s square plus omega square whole square, then what to do? I will overcome it by L inverse of s by s square plus omega square into s by s square plus omega square. It is a product of two functions, it is fs, it is gs, L inverse of fs gs is the formula is ft convolution gt, is not it? Ft convolution gt. So this is the inverse, here is here cos omega t, and the inverse here is cos omega t. But to evaluate this integral, it is integral 0 to t cos omega u into cos omega t minus omega u du. But to evaluate this integral, multiply 2, balance it half, and once you evaluate it, so the answer will be sine omega t plus omega t cos omega t divided by 2 omega. Okay, so once you remember this formula, this is just a formality, you can come back to this within no time. Okay, so this is the beauty of this convolution theorem. Now recalling another formula, as you know, Laplace of TFT is minus derivative of the Laplace of this Fs. Likewise, the question is, if you have Ft is divided here, then naturally integral s to infinity Fs ds. And similarly, if it is s is divided, so it leads to L inverse 1 by s Fs. Inverse will come from this integral 0 to t f of t dt. Similarly, suppose some twice s square is divided with Fs, then it will be, we need to integrate it twice, isn't it? 0 to t, then whatever you get it for 1s ft dt. So likewise you move. So now with this knowledge we can approach the problems. You know the Laplace transform is satisfy the linearity property. As you know, means you find L of ft plus minus gt. If some constant is multiplied here, then individually you can separate k1 L of f plus k2 L of f, isn't it? So we will implement this idea, and similarly for L inverse 2 also, this is also the linear. Okay, so now if I ask you find the Laplace inverse of 3 sin omega t plus cos square 2t plus 3 a to the power t plus 5 by root t, like that if it is asked, means you separate them out. So this will be here L of 3 taken out sin omega t, and you just write it, simplify it in by using trigonometry formula. So L of cos square t is, cos square theta is 1 plus cos 2 theta, it is cos 4t divided by 2, then plus a to the power t, you know the direct formula, it is 3 Laplace of a to the power t plus 5 Laplace of t to the power minus half. Okay, so now you apply the formula, you are ready to apply the formula. It is 3 omega by s square plus omega square plus, this is half taken out, Laplace of 1 is 1 by s, and plus Laplace of cos 4t s by s square plus omega square means 16 plus a to the power t 1 by s minus ln a plus 5, I have already told you it is pi by s root over. So this is your answer. Now the question is, if you are asked to find the inverse, suppose you are asked to find L inverse of 1 by s into s minus 1. So I am applying different techniques here. So you see, by simple means you can apply the partial fraction here, a by s plus b by s minus 1. Okay, so for the value of s, you put s is equal to 0 here and you close it, then it is minus 1. So this value of a will be minus 1. Similarly for value of b, you put s is equal to 1 here and just you close it, then it is here 1 by 1 is 1. So this will be my L inverse of 1 by s minus 1 by s minus 1. So you apply the formula here, it is here minus 1, it is here plus 1. So this is my minus Laplace of 1 is 1 by s, so Laplace inverse of 1 by s is 1, plus Laplace of e to the power at is 1 by s minus s, so it is e to the power t. So this is e to the power t minus 1. So I applied here partial fraction here. Partial fraction. For details knowledge of partial fraction, you can refer to my lecture series, lecture 6. Okay. So here I have discussed many varieties of partial fraction. So now let me to apply the convolution here. So L inverse of, I can write it 1 by s into 1 by s minus 1. So Laplace of inverse of this is here 1 and Laplace inverse of this here e to the power t. Okay, so you know it is e to the power t convolution 1. Always try to keep the second function simple because we know it is commutative also. So that will be equal to integral 0 to t e to the power u, and the constant will, that constant itself du. If you evaluate it, it is e to the power u 0 to t, substituting the upper limit minus lower limit, it is e to the power t minus 1. Okay, so you see now. So this answer is same as here this answer. Okay, so any method you can apply. So here we applied convolution theorem. So sometimes it will ask apply convolution to solve. You have to do that. Otherwise I can apply another function. Else I can apply here L inverse of 1 by s fs is integral 0 to t ft dt, is not it? So my here question is L inverse of 1 by s into 1 by s minus 1, is not it? So this is my fs. So what is its Laplace inverse? It is e to the power t, and because of this I integrated from 0 to t. Okay, so this is my e to the power t, integration is e to the power t plus 0 to t. So this is e to the power t minus 1. Okay, so this is your answer. Is it not same? So if nothing is asked, you can adopt any of the technique. Okay, so in many complicated case the inverse will better by convolution once you know the result only, otherwise the integration will lengthy. Okay, so the partial fraction is advisable in many cases. So for details you refer my lecture 6. If I ask you one more problem, find the Laplace inverse of s square minus pi square by s square plus pi square whole square. Suppose a problem is asked like this, then what to do? You have to split it out. It is L inverse of s by s square plus pi square. It is actually s square by this, so I split it s by s square plus pi square. Likewise minus L inverse of pi by s square plus pi square into pi by s square plus pi square. Okay, so I apply the convolution here. So this is equal to my cos pi t convolution cos pi t minus it is sin pi t convolution sin pi t. So now I know the applying the formula here, then I directly apply. It is cos omega t plus omega t cos omega t, omega is pi here, divided by 2 omega, and it is my cos omega t minus omega, it is sin omega t, just a minute. So the formula is sin omega t plus omega t cos omega t and divided by here 2 omega. Okay, for this I apply. Now here sin omega t sin pi t cancel. So this is here by 2, just a minute, by 2 omega means by 2 pi. So this will be equal to here pi t cos pi t by 2 pi. Okay, this is pi t twice pi t, so 2 pi cancel. This will be t cos pi t, is not it? So suppose it is asked use convolution to solve, then definitely you have to move it like this. Otherwise you know the formula here, L of t cos omega t is s square minus omega square by s square plus omega square whole square. So is it not that directly s square minus omega square? So directly you can write it. It will be here t cos omega t means t cos pi t. Okay, so this is my direct. If it is asked apply convolution, then you can apply it by convolution. If you apply partial fraction also, you will able to apply it. If you are asked to apply the partial fraction, okay, so it is direct. So therefore my L inverse of s square minus pi square by s square plus pi square whole square is t cos pi t. Okay, so similarly if you apply the partial fraction here, you can also apply the partial fractions. If one likes to apply, then it will be s plus b by s square plus pi square plus cs plus d by s square plus pi square whole square. You find ABCD. Okay, so this will be your L inverse of this. It is by partial fraction. Okay, so any technique you may adopt. Another important example I will say, question number 4. Exactly, I don't remember the number. So anyway, question. So suppose you are asked to find L inverse of ln s minus a by s minus b. So how to overcome it? Okay, so this is my fs. Okay, so solution, let my fs is equal to ln s minus a by s minus b. So you know ln a by b, ln a minus ln b. So this is ln s minus a minus ln s minus b. So now the moment ln is there, the derivative is quite easy. If I find the derivative, okay, if I find the d by ds of fs, I find d by ds of fs. So it will be my what? It will be my what? The derivative of this is 1 by s minus a. The derivative of this is minus 1 by s minus b. If I multiply a minus sign here, then I multiply minus here plus here. So now this is nothing but L of TFT, is not it? So you recall the formula L of TFT. So now L of TFT is equal to this. So this implies, what is my TFT? My TFT is L inverse of 1 by s minus b minus 1 by s minus a. So this is equal to your e to the power bt minus e to the power minus at. So what is your ft? Therefore your ft is, you just divide t it here. So this is equal to e to the power bt minus e to the power minus bt, sorry, at divided by t. Okay, similarly, if a question is asked, find the Laplace inverse of tan inverse s by omega. Okay, you apply the same technique here. You apply the same technique of derivative technique here, differentiation. Okay, so next, coming to the first and second shifting theorem. Okay, first shifting theorem is called S shifting. Likewise, the second shifting is called T shifting. Right? And in my detailed lecture, I have told you S shifting and T shifting. The detailed lecture is not there, so till now it is not prepared. Subsequently, I will upload a detailed lecture on T shifting. So I will just tell the background for solving the problems. So coming to your S shifting or fast shifting theorem. Coming to the fast shifting theorem, you know, if L of ft is fs, then L of e to the power at t into ft is f of s minus a. Okay, means here your s is simply replaced by s minus a the moment at is multiplied. Likewise, the moment e to the power minus at will be multiplied, then what will happen? S is replaced by s minus a, means s plus a. Okay, so we use it now. Likewise, if I ask L inverse of f of s minus a, then it will be e to the power at t into ft. So let me to solve some examples. If I ask what is L of e to the power at t into t to the power n. Okay, so we find the Laplace of this. Laplace of t to the power n is factorial n by s to the power n plus 1. Now because of this e to the power at t, what we have to do? We replace s by s minus a. Here we assume here n is a positive integer, we assume. So this will be here s is replaced by n factorial by s minus a to the power n plus 1. So this is because of the fast shifting theorem. Okay, so likewise, if I ask you what is Laplace transformation of a to the power t sin t, right? So a to the power t will play the role of e to the power. So a to the power t will play the role of e to the power ln a to the power t. It will simply a to the power t sin t, is not it? So that means L of e to the power t ln a sin t. So now this sin t will give you 1 by omega by s square plus omega square means 1 here, and because of this s is replaced by s minus ln a, is not it, because of the fast shifting theorem. So this is equal to 1 by s minus ln a whole square plus 1. Okay, so coming to one more important example. Suppose one example is, what is L of t e to the power minus t sin t. Then what to do? For sin t we have to work on this first, for t sin t we have to work on this, and thirdly we apply the shifting. We keep shifting for last. So we have L of sin t is omega by s square plus omega square. Omega is 1 here, so this implies L of t sin t, you know it is minus d by ds of this, but I am not going to differentiate it. I have already remembered it, so I already write it. It is 2 omega s by omega is 1, 2s by s square plus 1 whole square. So now I apply the shifting. So therefore L of e to the power minus t sin t. So this will be my s is shifted by s plus 1, is not it? So it is my twice s plus 1 by s plus 1 square plus 1 whole square. So because here s is replaced by s plus 1 because of the fast shifting theorem. So this is what my fast shifting theorem. So as a consequence of this theorem, I solve some inverse problems. One question is, find L inverse of 1 by s square plus s plus 1. You see, this is not possible to factorize, so I split it as a whole square and adjust plus minus 1 by, if I adjust it, it is s plus half whole square, means s square plus s plus 1 by 4. To balance it, we have plus 1 minus 1 by 4. You see, it is adjusted now, right? So that is equal to my L inverse of 1 by s plus half square plus it is 4 minus 1 3 root 3 by 2 whole square, is not it? So to make a formula here, apply a formula here, we need a root 3 by 2 here. So to balance it, we multiply, we divide it 2 by root 3. So this will be my 2 by root 3 because of s plus half e to the power minus half t, e to the power minus half t. Now you think it is omega by s square plus omega square. It is here sin omega t, sin root 3 by 2 t. Okay, so this is the answer. One more example I ask, find the Laplace inverse of, suppose s by s square plus 9s plus 10. You see, similarly the denominator cannot be factorized, so we think of the shifting. So this is my s by, I can make it s plus 3 whole square plus 1. Okay, so since in the denominator it is s plus 3, in numerator also we need it s plus 3. So it will be my s plus 3 by s plus 3 square plus 1. To balance it, I subtract a 3 here, then I separate them out. So this is my L inverse of s plus 3 by s plus 3 square plus 1 square and minus 3 L inverse of 1 by s plus 3 square plus 1 square. Now I apply the formula here. Because of s plus 3 here, I write e to the power minus 3t outside. Okay, then you simply think it is s by s square plus omega square, it is cos omega t, and it is minus omega by s square plus omega square, it is 3 sin t. So this is my answer now. Now before we learn the second shifting theorem, we need to know two most important functions here. One is the unit step function, what is also called as Heaviside function, and other one is my Dirac delta function. Dirac delta function. These two functions I should know. Okay. So what is your Heaviside functions? This Heaviside function is u at t, or it is denoted as ut minus a. So this is equal to 0 when t less than a, 1 when t greater than is equal to a. If I think of the graph of this function, means this function is like this. This function is like this. So when it is my a, so for greater than a, it is my 1 here. It is my 1 here. And less than a, it is my 0 here. So I just make it bold here. Okay. So this is the graph of ut minus a unit step function. The graph is like this. Okay. So this is the graph of this. It is t. So now what is the Laplace transform of this? The Laplace transform of this. So here likewise the Dirac delta function is del t minus a, or sometimes it is also written as del a t. So the definition is, so it is equal to infinity when t is equal to a, and 0 t not equal to a. That means at a particular point infinite force is applied. Okay. So it is the limiting case of the unit impulse function. At the same time we have integral the whole force 0 to infinity delta t minus a dt is equal to 1. The entire area under this curve which 1 means the whole force is applied at a particular point. Okay. So the details of this Heaviside functions and Dirac delta function I will tell in a separate video. However, I tell you here what is the Laplace of this. What is Laplace transformation of ut minus a? It is e to the power minus as by s. Accordingly, what is Laplace transformation of delta t minus a? It is simply e to the power minus as. If I ask you what is Laplace inverse of e to the power minus as, it is here delta t minus a. If I ask you what is Laplace inverse of 1, is it not your e to the power 0s? So you can say it is simply delta t minus 0, is not it? So here delta t. So you remember it. Many students commit mistake here. Laplace inverse of 1 is delta t only. Okay. So now this is all about your delta function, Dirac delta function, and for this is my unit step function. So now my most important thing is my second shifting theorem. The second shifting theorem says if L of ft is equal to fs, then L of e to the power L inverse of e to the power minus as into fs. Okay, L inverse of this is f of t minus a ut minus a. So this ut minus a here is the Heaviside's functions or unit step function. So likewise L of f of t minus a ut minus a. Okay, so this will be e to the power minus as into fs. Clear? So this is my second shifting theorem, right? And I will tell later on in a separate lecture this unit step function and Dirac delta function. These are the engineering function. This function is used to control the signal, right? Control the signal, and this function is used to deal with a very high force at a particular very high force at a point, at a particular point. So I will tell in separate video the details. Now I work on this. Suppose you are asked find L inverse of e to the power minus 2s by s into s minus 1. Okay. So this is L inverse of e to the power minus 2s into 1 by s into s minus 1. Already in question number 1 I have done it. So this is my L inverse of, this is your fs, is not it? This is your fs, e to the power minus as fs. So it is L inverse of e to the power minus 2s, and I have already solved the by partial fraction 1 by s minus 1 minus 1 by s. Okay, this. So you see it carefully here. You see it carefully here. So this is my fs. What is your fs here? Fs is 1 by s minus 1 minus 1 by s. So what is ft? Your ft is e to the power t minus 1, is not it? But what is a here? E to the power minus as. So what is a here? A is 2 here. But by the formula we need f of t minus a. So what is f of t minus a? So f of t minus a means here f of t minus 2 here. So this is e to the power t minus 2 minus 1. Is not it? E to the power minus as fs. So what is my answer then? By second shifting theorem, it will be my f of t minus a u t minus a, is not it? So L inverse of e to the power minus 2s 1 by s into s minus a. So this will be my this. So f of t minus a is my this, e to the power t minus 2 minus 1 and into u t minus a is my 2. Okay. So this is my e to the power t minus 2 ut minus 2 minus ut minus 2. So this is your answer. Coming to one more example. Suppose L inverse of s e to the power minus s by s square plus omega square. Okay. So now this is my fs. So this is equal to L inverse of e to the power minus s into s by s square plus omega square. The inverse of this you know. So what is your ft now? So my ft will be, so this is L inverse of, so you do one thing. What is your ft here? Ft is equal to, it is cos omega t. So ft is here cos omega t, but you need f of t minus a. F of t a is 1 here. So this is cos omega t minus 1. So now applying the formula here. So by a second shifting theorem it will give me, L inverse of e to the power minus s into s by s square plus omega square is f of t minus 1 ut minus 1. So f of t minus 1 you substitute here. So this is equal to cos omega t minus 1 ut minus 1. So this is my answer. So now I apply this second shifting theorem to find the Laplace transform of certain functions. Now apply the second shifting theorem to find the Laplace transform. So what is the formula here? This is the question. Suppose you know L of f of t minus a ut minus a is e to the power minus as into fs, right? So I call it, suppose it is my f of t minus a, right? So this is my f of, let my f of t minus a is my t square. So what is my ft? My ft is a is here 1 here, right? 1 here. So f of t means t is replaced by t plus 1. It is t plus 1 whole square. So this is t square plus 2 t plus 1. So what is your fs now? Fs will be here, it is 2 factorial by s cube plus 2 Laplace of t is 1 by 2, t is 1 by s square, and Laplace of 1 is here 1 by s. Okay, so what is the formula then? So therefore my L of t square ut minus 1, what should be my outcome here? It is a is 1, e to the power minus s into e to the power minus as into fs, is not it? So what is my fs here? So it is e to the power minus s by second shifting theorem. So I write it here, e to the power minus s, my fs is 1 by s plus 2 by s square plus 2 by s cube. So this is my answer. Suppose I ask you one more problem. Find Laplace transform of sin t ut minus pi. Okay. So let I think this is my of the form of f of t minus a is pi ut minus pi, right? Ut minus pi. So now what is my f of t minus pi? So this is my f of t minus pi is sin t. But what is my fs now? So t is replaced by t plus pi. So it is sin pi plus t. It is in the third quadrant pi plus t. So all sin tan it is negative minus sin t. So what is my Laplace of this? What is my ft now? Just a minute, it is here f of t. So this is my f of t, not fs. This is my f of t. Means I replaced t by t plus pi. So in the right hand side I replace it. So what is my ft here? Ft is minus sin t. So what is your fs now? So fs is minus of, this is omega is 1 by s square plus 1. So what is the answer then? So therefore by second shifting theorem, L of sin t ut minus pi is my f of t minus pi. Just a minute. So what is the answer then? It is e to the power minus pi s into fs, is not it? So I apply it here. So it is e to the power minus pi s into fs, means minus of 1 by s square plus 1. So this is my answer. Okay, so this is my answer. Now I discuss two more important things, what I call the application of Laplace transforms. So first one is I solve here solution of ordinary differential equation. What type of initial value problem? So to discuss this, we have to know what is Laplace of yt. It is Laplace of yt is here ys, or I simply call it my y. What is Laplace of y dash? This is my sy minus y0. Laplace of y double dash, it is my s square y minus sy0 minus y dash 0, right? So for details you should refer to my lecture series, the special lecture on this for details. So for details you refer to my lecture 8 on Laplace transforms. Okay, so now at best up to second order differential equations we are given, and these are initial conditions are needed. Okay, so now let us solve a particular question here. Suppose you are asked to solve, use Laplace transform to solve this differential equation, and I have told you this is a IVP, initial condition is given. Okay, this has to given, otherwise we cannot solve it. So now apply this detailed solution, taking Laplace transform to both sides. You have L of y double dash is s square y minus sy0 minus y dash 0 plus your Laplace of y. Laplace of y is simply capital Y. Okay, so in right hand side this is 3. Laplace of cos omega t is s by s square plus omega square. Omega is 2 here, so it is 4. Now you apply the condition here. The value of y0 is 0, the value of y dash 0 is 0. So this will be my s square, y taken common, it is s square plus 1. Okay, so this is equal to 3 into s by s square plus 4. So that means what is your y? Y is 3 by 3 into 1 by s square plus 1, bringing this to this side, and it is s by s square plus 4. So now it is the time to apply the inverse Laplace transforms, taking inverse Laplace transform to both sides. So this is L inverse of capital Y, means it is a function of s. It is 3 L inverse of this product form, s square plus 1 into s by s square plus 2 square here, is not it? So you apply the convolution theorem here. L inverse of fs into gs is ft convolution gt is sin, it is sin t, and it is your cos t, and you know it is cos 2t, it is your cos 2t, and already you know the formula. It is 3 integral 0 to t f of u sin u into cos 2t minus u, 2t minus 2u, f of u g of t minus u. Okay, but you are not differentiating it exactly, you are not integrating it. We already remember the formula. Laplace transformation of sin omega t cos omega t is t sin omega t by 2. So this will be So the formula is sin omega t convolution cos omega t is t sin omega t divided by 2, is not it? So we use it. So t sin omega is my t sin omega t. Just a minute. Just have a correction in the question. The question is, it is here 4y, okay, 4y. It will easily get the result. I use it 4y. However, for 1 it's also fine, no issue, right? Because it will come under sin omega t convolution cos omega t. Otherwise you have sin 80 convolution cos bt, that thing. Since I want to apply the direct formula, so this is t sin 2t here, okay. So this will t sin 2t by 2. So this is 3 by 2, okay. Otherwise you have to think of sin 80 convolution cos bt. So we have to work the details on work. I want to apply this formula to avoid here, to save your time, because we don't have much time. We have to cover the entire thing here. That's why I make the changes in the questions. Now we come to the another question. Now solve one more problem. Solve by using Laplace transform, okay. So likewise, you taking the Laplace transform to both sides, you get, taking Laplace transform to both sides you have s square y minus sy0 minus y dash 0 minus 4 sy minus y0 plus 3y is in the right hand side. It is Laplace 6 by s square minus 8 by s. Now apply the conditions here. This is my 0 and this is my 0. This is my also 0. So this implies my taking y common, y into my s square minus 4s plus 3 is my right hand side. I just add it, 6 minus 8s by s square. Now you divide it in the right hand side. So that means y is equal to here 6 minus 8s divided by s square. Just I make the factorization here, s minus 1 into s minus 3, s square minus 4s, okay. So I just apply the factorization here. So just do factorization of this is this. So now you apply the partial fraction here. It will be here a by s plus b by s square plus c by s minus 1 plus d by s minus 3, okay. So now to get the value of s, b, you put s is equal to 0 and close it. To get the value of c, put s is equal to 1 and close it. Similarly for d, if you simplify it, the value of a will be here 0, the value of b will be 2, the value of c will be 1, the value of d will be minus 1. So this will be my 2 by s square plus 1 by s minus 1 plus minus 1 by s minus 3 in capital Y is equal to this. So taking inverse Laplace transform. This is your yt, and the inverse of this is 2t. Laplace of t is 1 by s square plus it is e to the power minus t, and it is minus e to the power 3t. So this is your answer. Now coming to one more problem where your unit step functions are involved. Coming to suppose another question. Solve by using Laplace transform, okay. Suppose a question is asked, solve by using Laplace transform. So here it is the Dirac delta function. Already you know L of delta t minus a is e to the power minus s. So taking the Laplace transform to both sides, what we are getting, s square y minus sy0 minus y dash 0 plus here y is, it is e to the power minus as only, so it is e to the power minus 2s. So substitute the condition here. This is here 1 and this is here 1 also. So now these two taken together, so this implies my y into s square plus 1, okay, minus s minus 1 is e to the power minus s minus e to the power minus 2s. Now bringing this to right hand side, we have So that means my y into s square plus 1 is equal to e to the power minus s minus e to the power minus 2s plus s plus 1. You divide it here now. So your y is equal to e to the power minus s into 1 by s square plus 1 minus e to the power minus 2s into 1 by s square plus 1 plus here s plus 1 by s square plus 1. Okay, so now taking inverse Laplace transforms, what you are getting, this will be your yt, and you apply the second shifting theorem here. We apply the second shifting theorem here. Okay, this is the second shifting theorem. So this is my f of s. F of s will give you sin t. What we need? F of t minus a. So sin a is my 1. Sin t minus 1 ut minus 1. So accordingly it is my sin t, and a is my 2, sin t minus 2 ut minus 2, and it is separately s by this. It will give you your cos t, and plus it will separately your sin t. So this is your answer now. Suppose coming to another problem, solve by using Laplace transform, here. Of course, because the right hand side is this engineering functions here, without Laplace transform we cannot solve this. The initial condition must be given here, y0 is equal to 0 and y dash 0 is equal to 1. Okay, so that second shifting theorem will help you. As usual, you take the Laplace transform, it will be your s square y minus sy0 minus y dash 0, and the Laplace of this is 5 sy minus y0 plus here 6y. In the right hand side it is e to the power minus as by s, e to the power minus s by s, and plus it is delta t minus a. It is simply e to the power minus 2s. You apply the condition here, y0 is 0 here, y0 is 0 here. Okay, so now collecting y terms together, y into s square plus 5s plus 6, and bringing this to right hand side, it is e to the power minus s by s plus e to the power minus 2s, and bringing this y dash 0 is my 1 here plus 1. Okay, so now I simplify it. So this implies my y will be equal to, the factorization of this is e to the power minus s into 1 by s into this factorization is s plus 2 into s plus 3. Okay, similarly it is e to the power minus 2s into 1 by s into s plus 2 into s plus 3, and plus here 1 by simply s is not here, 1 by s plus 2 into s plus 3. So as usual you apply the second shifting theorem here, apply the second shifting theorem here, and apply the partial fraction here. Okay, to get the answer. So likewise in the previous case you should get the answer. For detail of study you should refer to my lecture 9 for details, but I will tell you the basic things to solve the problems here. So as you know, this convolution theorem, L inverse of, what is the convolution theorem? L inverse of fs into gs is ft convolution gt, is not it? So it is your integral 0 to t f of u g of t minus u du, is not it? So taking L to this side, so my L of ft convolution gt is simply my fs into gs, or it is nothing but L of ft into L of gt. So this is what I am going to use it. Suppose you are asked to solve a problem here. Solve. The question is, so now you are asked to solve this. So this is a integral equation, because you see your y is coming under the integral sign. You see my details lecture 9 here. So now I just express it here. It is t square by 2 minus, and this you express it in terms of convolution, yt convolution of t, is not it? So now minus yt. So now taking the Laplace transform to both sides, so this will, y will be equal to L of t square by 2 minus L of yt convolution t. You already know L of this is individually L of this into L of this. So this is your t square by 2 is 2 by sq, 2 cancelled, it is your 1 by sq minus individually this is y into this is 1 by s square, is not it? So now bringing this to this side, so that means my y into here it is 1 plus 1 by s square is 1 by sq. So that means my y into s square plus 1 by s square, this is equal to 1 by sq. So now this s square and this I'll bring it to that side. So that means my y will be 1 by sq into s square by s square plus 1. Okay, so now s in this, so this will be my s by s square plus 1. Just a minute. So here it is, here 1 by s into this. Okay, now we need to apply the inverse Laplace transform. I have already told you the several approach. Okay, so how to find this? So taking inverse Laplace transforms. So this will here yt will be your L inverse of 1 by s into s square plus 1. You know the different approach to find this. If I apply the partial fraction here, then it will be my L inverse of 1 by a by s plus bs plus c by s square plus 1, s square plus 1. Okay, so you get the value of a, b and c. So if you simplify it, you will get a is your 1. Okay, so that will be your L inverse of 1 by s plus L inverse of it is minus s by minus 1, so minus of s by s square plus 1. So this is your 1 and this is simply cos t. If you apply the other way also, if you apply the convolution here, can you not write it? It is 1 convolution sin t, 1 convolution here sin t. Okay, 1 convolution sin t, or you can write it sin t convolution 1, and you can get the answer also 1 minus cos t. The other aspect is you can also apply 1 by s fs integral 1 by L inverse of 1 by s fs is integral 0 to t ft dt. You can also apply that also. So that will be integral simply 0 to t. Okay, integral 0 to t here sin t dt. Also it is resemblance to this also, is not it? So this is 1 minus cos t. So this is the answer. So means you may approach any technique to get the inverse. So the main motto of this lecture series is, right, to tell all these things simultaneously, so that you apply any technique you like, provided you have a thorough knowledge on the individual topics. Then only this lecture will helpful to you. Coming to one more example. So another question is yt is equal to yt minus this. Okay, so you see now so you first apply it is an integral equation, because in under the integral sign you get it. So this is equal to 4t minus 3, you express it, it is yt convolution of sin t, is not it? So now you take the Laplace transform here, taking Laplace transform here. In left hand side it is your y, in right hand side it is 4 by s square minus 3, individually Laplace of this is y and Laplace of this is 1 by s square plus 1. Now bringing this to my left hand side, so that means my y into 1 plus 3 by s square plus 1. Okay, so this is equal to 4 by s square. So you simplify it, y into s square plus 4 by s square plus 1 is equal to 4 by s square. Now so this implies your y is equal to 4 by s square into s square plus 1 by s square plus 4. Okay, so now you find your yt will be L inverse of this 4 by s square into s square plus 1 by s square plus 4. So you should solve it of your own to get the answer. Let me to solve one more problem. coming to one more important problem, yt is equal to this. Okay, so you see, to get a sense, we should have some f of u gt minus u. We need a term like this to apply the convolution here, so we bring this inside here. So this will be here t to the power t minus 2i's integral 0 to t. Let me write it first, yu. Now this multiplied it will e to the power t minus u du, isn't it? So now it is of this form. This is f, this is this, so I can write it t e to the power t minus 2i's. It is my yt convolution of e to the power t. Okay, so now I can take the Laplace transform to both sides. This is my y is equal to, I apply the shifting theorem here. Laplace of t is 1 by s square, because of this 1 by s minus 1 whole square, minus 2i's. Laplace of this is y, and Laplace of this is 1 by s minus 1. Now bringing this to this side, so that means my y into 1 plus 1 by s minus 1 is 1 by s minus 1 square. So that means y into, it is my s minus 1 plus 1 by s minus 1 is 1 by s minus 1 square. So now I solve it here, bringing this to this side. So that means my y is equal to 1 by s minus 1 square into s minus 1 by s. So this is equal to 1 by s into s minus 1. Okay, so I can simplify it. Just a little correction here in the right hand side, it is 2, so it will be 2. Accordingly it is simplified to get it. So this is here a by s minus 1 plus b by s plus 1. If you solve it, the value of a will be half, the value of b will be minus half. So this is equal to half 1 by s minus 1 minus 1 by s plus 1. So taking the inverse, so this implies my yt will be equal to L inverse of this. Okay, so this will give you, so this will give you half e to the power t minus e to the power minus t. You may leave it, or otherwise this is nothing but my sine hyperbolic t. So this is your answer. Okay, so this is all about your integral equation. I just tell you one more thing, how to deal with the discontinuous function or a signal. A graph is given, how to find the Laplace transforms. So one signal is given to you, find the Laplace transform. A signal of this form is given, suppose it is t, it is your ft. Okay, now it is up to is here 1, this is the graph, and up to 2 this is the graph, and onwards it is 0. Okay, so now this question is split into 3 parts. Of course this value is given 1. So what is your ft now? So this ft is split into 3 parts here. One is from 0 to 1, and another one is from 1 to 2, and next is greater than 2. Okay, so here the graph is parallel to x-axis, so y is equal to constant, means here ft is equal to, here it is here ft is equal to 2 here, isn't it? Ft is equal to 1 parallel to this at a distance 1, and here it is ft is equal to 0, isn't it? So this is my ft is 0 here, and here my ft is 1. Now I need to find it, since this is 1 and 1, it is y equal to x, means ft is equal to t. So this is the graph. So what is my L of ft now? You apply the definition technique, integral 0 to infinite e to the power minus st into ft dt. So looking into the question, you split it. So this is integral 0 to 1 plus 1 to 2 plus 2 to infinity e to the power minus st into ft dt. So this will be, here it is 0 given, so now here it is t, integral 0 to 1 t e to the power minus st dt plus integral 1 to 2, this is here 1 into e to the power minus st dt. You just simply integrate it and solve it. So let me to solve the last question. A signal is given like this. So accordingly, this is the signal is splitted here. This is origin 0 0, and this point the coordinate is, it is my, suppose x-axis 1, y-axis 1, and here this point is suppose my 2. It is my b 2 0. Okay, so what is the function then? So ft is splitted into three parts. One is 0 less than t less than 1, and another is 1 less than t less than 2, and another one is 2 less than t less than infinity. Now this is your 0 here, it is quite usual, and this is my OA graph, OA straight line, and this is my AB straight line. Okay, so you know you have to find the equation of straight line passing through x1 y1, this is A, and x2 B, x2 y2. What is the equation of the line? Y minus y1 is y2 minus y1 by x2 minus x1 into x minus x1. Okay, accordingly what is your y here? Y is your ft here. So if you solve it, this will give you your 2 minus t, and this is 1 and this is 1, it will give you t. Okay, so what is the question now? So the question is now your ft is equal to t 0 less than t less than 1, and ab is here 2 minus t 1 less than t less than 2, and 0 otherwise 2 less than t less than infinity. So accordingly, what is L of ft? L of ft is integral 0 to infinity e to the power minus st into ft dt. So looking into this, you split the integral, it is integral 0 to 1, the ft is here t e to the power minus st dt plus integral 1 to 2, ft is 2 minus t e to the power minus st dt, and otherwise plus integral 0 to infinity, the function is 0. Okay, so you should get it, apply by parts and solve it to get your desired answer. So to conclude, this 1 hour and 10 minutes lecture covered the almost all things of the Laplace transforms. However, I repeat, for thorough knowledge, the overall knowledge, you should see the individual lectures. Otherwise, you cannot have expertise over the all topics. So you must see the previous individual lectures. After that, you see this 1 hour and 10 minute lecture, and this will help you. Okay, so now if this lecture is interesting to you, or you find that it is useful to you, I request you to subscribe this channel, so that it will motivate me to upload the similar video for your benefits. So we should close this video then. Thank you all. Have a nice day.